So the last week's series of lectures really dealt with picking apart the idea of the mole, using the mole as a surrogate for molecules. In this example, we have 6 lithium atoms are reacting with 1 nitrogen molecule to produce 2 lithium nitride ionic compounds. Now, certain elements like nitrogen and a handful of other ones exist as diatomic molecules. Those are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and is there one I'm forgetting? Well, if I'm forgetting one, I'll put it up here. All right, but these, it's usually that corner of the periodic table. That upper right-hand corner, almost all of those exist as diatomic molecules. So when you read nitrogen in a problem or hydrogen in a problem, they're usually talking about elemental hydrogen, which exists as H2. Again, chemistry's long tradition of confusing the student. So, going back to our problem, we have this idea of molecules and atoms expressed in our balanced chemical equation. Now, we then shift into the macroscopic when we deal with masses of material. And in the last set of lectures, we talked about how to convert the mass of a compound into the moles of that compound. And again, mole is a surrogate for molecules. And so we can then relate this balanced chemical equation to moles. 6 moles of lithium reacts with 1 mole of nitrogen gas to produce 2 moles of lithium nitride. These together allow us to convert from one mass quantity into any other mass quantity and make predictions. Now, let's start with this problem real quick. Just again, this is just review. 3.00 grams of lithium are reacted with excess nitrogen to produce lithium nitride. And they want to know how much mass is formed. Conceptually, if we were to map this out, we'd convert our grams of lithium into moles of lithium using the molecular weight of lithium, which happens to be provided, and then moles of lithium into moles of lithium nitride using the stoichiometry. And lastly, we'd convert this moles of lithium nitride into grams of lithium nitride, because that's what the quantity question is asking us for, a mass. Now, to set that up, again, the same idea would be applying. We'd take this 3.0 grams of lithium, and we'd use that relationship from the molecular weight. Grams of lithium is equivalent to moles of lithium, a certain number of grams. And then we would continue on from our moles of lithium. We'd convert our moles of lithium into moles of lithium nitride. And we would use our stoichiometry for that. And lastly, we would take those moles of lithium and convert them into grams of, those moles of lithium nitride and convert them into grams of lithium nitride. And where would we get those numbers? Again, those numbers for the equations, and this would be using the molecular weight of lithium nitride. We had attained those numbers from there, or from the balanced chemical equation. We can see that 6.941 grams of lithium is equivalent to 1 mole of lithium. Again, that's our definition of the molecular weight of lithium. And we can then use the stoichiometry, which says that for every 6 of these lithiums, that is equivalent to 2 lithium nitrides. 6 of the lithiums is equivalent to 2 lithium nitrides. And then going back to our definition of molecular weight, 1 mole of lithium nitride is equal to 34.83 grams of lithium nitride. Plug that all into our calculator, multiply everything by the top, divide everything by the bottom, and you're golden. Very typical problem. In fact, it's incredible. It's so typical. It is the stereotypical chemistry problem. And it will serve as the starting point for many of our calculations. So be able to master this one. Now, we don't just have to focus on the product. As we're going to see in the next few slides, is that sometimes it helps to also make comparisons or extract implied information in other fashions. For instance, how many grams of nitrogen are needed to complete this reaction? If we were asked how much nitrogen was left over, or if we're like in a chemical plant and we're trying to figure out how much material we need to buy, this is a very germane question. So, how many grams of nitrogen are needed for the reaction? Again, map this out. Map it out, the prediction that you would use. Turns out that it's the same basic series of steps. Grams of lithium to moles of lithium to moles of nitrogen to grams of nitrogen. And this would allow us to predict how much nitrogen is needed for the reaction. So set that up and you should get the following answer. 2.02 grams of N2 are needed. So that's just a quick review of last week's topics.